We are now live and recording. Alex is ill, so he's not here. So I'm hosting again, which means no one will ever watch this video.
Yeah, we need to be better actually at linking them from the wiki.
Yeah.
I'll try to spend some time doing that.
Can you take control? Somebody's at the door. Sorry.
No problem, Chris. But anyway, I'm just gonna. So the topic we wanted to cover today is the progress that has been made by Ludovic on the whole tiering story. So when you have a cache that has on heap and disk tiers, because that's the current options Ehcache 3 offers.
So far, yes, but hopefully in the close future we'll propose also other tiers like clustered tier.
Yeah.
Where should we start? Should I show some code? I'm not sure it's a good idea. At least not now. Maybe later on. Maybe we should first discuss a little bit the tiering that we decided to go. It has been designed by our team quite some time ago in Montreal, so that's why we call it internally the Montreal design. And the idea is, yeah.
And it's the design that's in place in the Ehcache 2X line, by the way.
Correct. Yes, that's the design that is in Ehcache 2, at least the latest.
So I think from 2.6 or 2.7 at one point.
Yeah, it was introduced in 2.6 or 2.7. So it's been there for years, and it's been working on production for years. It's fine. And the idea behind it is that you have multiple layers of caching, well, that are generally storing in different places, like on the cluster, on your disk, off heap, or on heap. And the idea is the deeper you go in the layers, the slower it is to access the data, but the larger the data store is. So the cluster usually is the slowest and the largest. Then comes the disk, then comes off heap, then comes on heap. So the idea is to build a pyramid, each time having each layer of the pyramid having a subset of what's below it. Kind of. I'm making shortcuts here, but let's keep it simple for now. So you have a hot set, and then a hot set of the hot set, and a hot set of the hot set of the hot set. That's the idea. You build a pyramid. So for this to work and to provide all the features we want, like for instance, kind of consistency, the bottom tier is what we call the authority, meaning that whatever is in any above tier must be in the authority. So you cannot have something that is on heap but not on disk, for instance, if you have those two tiers.
Yep.
But when you have multiple tiers, that was the innovation that we came up with in the Montreal design. Like if you have multiple tiers, say cluster, off heap, and on heap, well, cluster is the authority, fine. But what is in the on heap and off heap doesn't matter. As long as it's in the authority, it doesn't matter. So it could be that what's on heap is not off heap. So those two are not completely consistent. It's okay because the consistency comes from the authority. The idea is that they just provide some caching on top of the cache. So that's it with the basic idea. What else can I say? In Ehcache 2, of course, everything follows the Montreal design except the cluster store. In Ehcache 2, did I say that?
Yeah, but we shouldn't mention too much the closed source bits anyway. So, but otherwise, in Ehcache 2, you have the Montreal design when you have an on heap and disk cache.
And you have kind of something that looks like the Montreal design in cluster, but it's really complex. And it's going to be completely refactored for Ehcache 3. And Ehcache 3, we are going to have the Montreal design for absolutely everything. Well, at least that's my understanding and my hope.
Yep.
What else can I say? Yeah, as you said, but it's good to repeat it. So far, we only have 2 tiers implemented: disk and on heap. So that's all you can do for now. Later on, we'll add more. That's pretty much it for the overall description. Should I go to? By the way, people here, how familiar are you with the Ehcache 2 code
By
of that
people here,
part?
do you mean the 4 of us, or 3 of us rather, or the people potentially watching?
The
I
3 of
think he
you, of
means
course.
us.
Fairly familiar.
Fairly familiar. Well, then this shouldn't come to a surprise to you.
If you could make
Okay.
that font slightly bigger.
I was about to go to presentation mode.
Cool. I'm also going to make you present to everyone so that it's captured properly.
So now, I want to go to the core class, which is the cache store. And of course, it's not there. What did I do wrong? Live.
Yeah, you tried to present something, that's really wrong.
Yeah, so foolish of me. How can I exit that now? Oh, there. No. Oh, great. How does that work? Ah, there it is.
You're on master. You need to be on your branch. That's the issue.
Ah, so smart, Louis. Thank you.
It's what Ludovic is showing us. He's not yet merged. So
while Ludovic is grappling with Git and stuff, I may have to drop out every now and again, and the remediation guys are here to look at the water leak.
It's okay. You're familiar with that, or you're supposed to be familiar with that, so.
Sure.
Good. Right, so this is the core of the real meaty, the piece of meat here. The cache store. That's what implements the protocol between the caching tier and the authoritative tier that you have here.
okay, and so that's what's used as soon as you have more than one tier. Because if you only have one tier, which is on heap, then you don't have a cache store, you directly have an on heap store, which is what exists today in Ehcache 3. Correct?
Correct.
Yeah.
All that code is not completely glued in. So there are still some corners that I need to cut. So that's why, by the way, it's not yet merged in, but that will happen really soon, like most probably tomorrow. But yeah, that's the idea. If you just configure one tier like on heap, well, you just get directly to the on heap store. But as soon as you configure more than one, then you get the cache store with some caching tier and some authoritative tier. The caching tier can contain multiple stores. The authoritative tier is always one single store. Those are 2 new interfaces. So let's first have a look at this one. And as you can see, it extends store. Very important. So it really is a store that provides 2 new services, flush and fold and flush. The idea of a fold is, since when something is in a higher tier, it cannot be evicted from the authoritative tier. So the idea is when a higher tier, when you want to put something in the higher tier, first you fold it from the authoritative, saying it's a simple get plus it puts a marker saying you can't evict that. That's what fold does, and it's atomic. So it's a get plus put a marker to avoid eviction. And flush is basically the opposite. It says, okay, you can start evicting that again. Okay, back to the cache store. And caching tier, on the other hand, doesn't extend from a store. It needs to be cleaned up a little bit because there are the life cycle methods here. We discussed them with Alex, and we were not sure if they should stay here or if we should move them to another interface. That's probably what's going to happen. And basically what you get here is, well, you get classic methods like get, remove, clear, and some new stuff like add eviction listener, a special eviction listener, check if something is expired. Oh, by the way, this is the interface of the eviction listener. And this really special method, get or compute if absent, that does exactly what its name says, meaning it's horribly confusing. What does that one do? Well, it's either a get, so if the caching tier contains the value, it's going to return it. But if it doesn't contain the value, then it's going to use that function to create the value and fill itself. Make sense? If we combine that with a fault, we get the basic idea of the Montreal design. So let's show you cache tier, grab cache store, I mean. Let's look at get, store.get. First, we go to the caching tier and we do get or compute if absent. If it's in the caching tier, it's going to be simply returned in the value holder. Here, we do some exploration here. I'll come back to that later on. And then we simply return the value. So if it's present, we simply return the value. If it's not present, then this is going to be executed. Authoritative tier fault. So get plus mark as not evictable. That's going to fill in the caching tier, and that's what is going to be returned. Got it? And when the caching tier is getting too filled up, too full, it needs to evict. Basically, this is when we have this special eviction listener. When the caching tier is evicting something, we flush it back. So it can become evictable again in the authority. And the rest, well, it's rather classic. Some implementations, well, most implementations so far are rather not too well optimized, except for the one that seems to be, as far as I could tell, the real hotspots. I optimized those two, get and compute if present or compute if absent, because those are the real hotspots. The other ones, they're rather simple, if not to say simplistic. What else can I say about that? You have questions, maybe?
So I remember we discussed offline at one point that the current implementation of Ehcache, so the cache itself, on the get path does a store compute if absent, which will then call here in the compute if absent. When does the gets called? You know what ends up? Yeah.
Calling store.get. As of today, nothing. So this is another discussion I had with Alex a couple times, saying, well, if the Ehcache class does everything with compute methods, why shouldn't we get rid of get, remove, and all those methods and put from the store interface?
Yeah.
And he answered, well, I want to keep both so far because you never know. Maybe down the line we will figure out that we need them.
So from my point of view, I'm strongly suspicious that when we bifurcate the cache implementation between, because okay, let me Take a step back. I believe that we are going to end up very soon bifurcating the cache into things
Cache
that
aside and
take. Yes, caches that have readers and writers and caches that don't. And when that happens, the ones that don't are highly likely to stop calling the compute methods.
Is that even true?
Probably not.
Maybe then we should have two kinds of store. I don't know.
Oh, well, I don't think we need that, but I'm just looking at. Yeah, no, it's true. In Get, it's purely interaction with the loader writer that we do. If we
the function
split,
would be. I mean,
we
there may
don't
be no
need
point in
that
keeping
much.
a compute. The function would be a return null. So that's my justification for why they still exist. Yeah, say something like. Well, it seemed like you were.
I'm thinking. So I'm thinking based on again offline conversation. Can you show the implementation of compute if absent, which is the other path that you optimized?
Where is it? Where is it? Where is it? Where is it? Oh, I skipped it. There.
Because I'm starting to wonder if we should not implement compute if absent as again with regards to caching tier dot get or compute if absent. Yeah, but maybe it's not needed. Which would give us the benefit of doing the folding in line, which is one item we discussed.
Yeah, maybe we could do that. But
yes, it feels a little weird that this is done. It feels like there's a mix of two different modes of operation here.
I think when you to be potentially have a look, Ludovic. No need to solve that now, but I'm starting to think that if you called here caching tier dot get or compute if absent, passing in a function that does what the get path does, but if it finds nothing, then invokes the mapping function which is passed here, you end up having the proper behavior.
yeah, that's a good point.
And that resolves the questions we had around synchronizing all of that. Although we've said that we probably don't need it, but I know we discussed it. So.
Yeah, I'll consider that. Let me write that down as a note.
Because then it might be interesting to realize that caching tier doesn't need a get.
Yeah, that's a good point. I didn't like the fact that I needed to add that. It would make me happier.
Yeah.
More gunk.
Okay, and so in the state you have it here, it means that you can start on your branch at least creating an on heap plus this cache that works.
Yes, that's true. Cache, store, SPI test. This is exactly what I'm doing here.
Okay.
I mean, I think the thing to bear in mind here is that every time we've tried to do this, we've never nailed it right the first time.
No. I fully understand, and that's why I'm the remarks I'm making are like purely conjectural, and I'm not implementing them. But
yes,
but I fully agree that I think we have a pretty good idea of what we want to do.
Mm-hmm.
We know some pieces of the code are getting too much complexity, and so I believe we need to think about the stuff that makes sense at one point. We need to look at if we can apply it elsewhere, and then simplify stuff. And so potentially if at one point we say, okay, we managed to actually get rid of get on the store because we realized that by using a compute and passed in function, we simplify the whole logic, then for me that's good. Because here we discuss potentially removing it from caching tier, and then again we have the discussion about, for the moment, store. So in the sense the store API, store.get is never called as of today. Okay, that's
There's a lot of room for simplification, a little bit all around, but I think it's still too early to start some cleanup.
I agree with that. We need to have clearly a two-tiered, at least, completed, and then we can start about pruning stuff off, especially for internal APIs. I mean, come on.
Yeah. That's more or less what I had in mind.
Yeah.
Cool. Yeah. I hope everybody learned a little bit of something.
Just a little bit. Not learn too much.
It's better than nothing at all.
So I remember a lot of complexity leaking in Ehcache 2x. Does that mean you managed to clean up a few corner cases by having a proper, a better, from the start design?
Yes.
Or is it just that I'm remembering the complexity here, but it's actually elsewhere?
There was quite some complexity in Ehcache 2 that was due to backward compatibility.
Okay.
For instance, in Ehcache 2, the cache store uses a read-write lock just for the sake of having a backward compatible implementation of flush. Some concept that we absolutely don't have at all in Ehcache 3, so we got rid of that lock.
Okay, and so it means for you, so you did the implementation of the disk store that was just answering the store API. And so moving from disk store to the disk authority, was that not an issue and pretty much easy?
Yes, it was really easy for the simple fact that the disk store also is a port from Ehcache 2. It already had on the inside everything that is required to do the default and flush.
Okay, so it had the bit that's needed to mark an entry as non-evictable and stuff like that.
Yes.
Okay.
The bit was already present. All I needed to do is just make sure to call the right method to mark it. Yeah. Change the glue.
That's good.
Yeah, so that part was quite easy. And by the way, this implementation is a lot cleaner and a lot simpler than the one in Ehcache 2, but I suppose you've guessed.
That's what I'm saying. Good.
Okay, can you stop? Can I do that myself? Stop
you
presenting
should be able to
my
stop
face.
yourself presenting. I can do it. I just did it. You
It
can do it
didn't work.
yourself, but I stopped you.
Thank you.
Did anybody have anything else they want to bring up? I don't believe there were any other topics that I was aware of, but I've been a bit out of the loop on.
No, I believe that's it. From the stuff we discussed in the past, progress has been made on the logging. We're still working on the plan we agreed for 107 extensions and how to integrate the whole XML configuration template versus the 107 defaults and stuff like that. And the rest of the
Right.
activity recently has been mostly bug fixing with regards to what was already in the alpha version.
Right. Yes.
Yep.
Cool. Right. I call this meeting to a close then.
Yep.
Early, about the first time ever. Because we don't have any debate, just information dissemination.
Yeah,
No, but
because
it's
everything I did was just perfect.
Obviously, that's why.
good.
That is now a recorded statement.
Of course, for the world to see.
Cool. I will let everybody go, and I will go and see how much of the house the remediation people have torn apart already.
Oh, good luck with that. Thanks, guys.
Cool.
Thanks.
See ya.
Bye.
See you all.